The 60-kilogram students are standing 4 meters apart. What's the magnitude of the gravitational force each student exerts on the other? So there is a student and there's the other student, and their distance between them, the distance between them is going to be 1 meter. And we are going to apply this equation. And so 2.4 times 10 power minus 7 Newton is going to be the answer. Earth has a period of 1 year and an average distance to the Sun of 1. If the average distance between Saturn and the Sun is 9.54, what's Saturn's period of revolutions? So, according to Kepler's third law, you can find this equation. So we are going to apply this. So the period of revolution of Saturn is gonna be 29.5 years. The planets A and B orbit the star in elliptical paths. The semi-major axis of planet A has a length 1L and semi-major axis of planet B has the length 16L. If planet A orbits with period T, what's the period of planet B's orbit? So again, according to Kepler's third law, we can find this equation, and we can solve this problem by using this. So the period of planet B's orbit is gonna be 64. A person exerts an earth force of 110 Newton to accelerate the 10 kilograms ton of earth. The acceleration of the stone is. So mass is 10 kilograms and upward force is gonna be 110 Newton. So We are going to apply this equation. So the acceleration of the stone is gonna be 1.2 meter per second. The motion of train A and B is parallel tracks. Train A passes train B, start from rest and R is 0. How far does train A travel between t is 0 and t is 50 seconds? How long does it take train B to catch up with train A? So train B starts. Firstly, train B starts from rest and travels with constant acceleration. So we are going to apply this equation. So we can find the value of 1,250 meter, and the distance train A traveled is gonna be and the distance train B traveled is gonna be this. So we are going to use these equations. So we can find 40 seconds. So the distance we find in the first question is going to be 1,250 meter, and the time we are finding is going to be 40 seconds. A resultant force of 10 Newton is made up of two components. First is acting at right angles to each other. If the magnitude of one of the components is 8 Newton, what's magnitude of the other component? So there is two components, and this is their right angle, and this is 8 Newton. Then this is made by these two components. Apply to Pythagoras theorem to find the rest value. So we're going to apply to Pythagoras theorem, then we can find these. So the magnitude of the other components is going to be 6 Newton. A ball that's thrown straight up with an initial velocity of 20 meters per second. The ball is catched at the height above the ground from which it started. The ball rises to a height of about. What length of time does the ball remain in the air? So initial velocity is gonna be 20 meters per second, and ball is thrown straight upward. At the highest point, the final velocity is gonna be 0 per meter per second. So we are going to apply this equation. So 20 meters is going to be the answer of the first question. The time is the time needed to get to the highest point. So we are going to solve the second question and we are gonna be apply this equation. So the total time is gonna be 4 seconds. The length of time the ball remains in the air is gonna be 4 seconds. A 30-Newton wooden block is at rest on a smooth wooden table. A force of 12 Newton is required to keep the blocking moving at constant velocity. What's the coefficient of friction for the block and the table? So this is gonna be our table and this is our block. And we are going to find this friction force. And for finding coefficient of friction, so the coefficient of friction for the block and the table is going to be 0.400. A force of 3 Newton and a force of 4 Newton are exerted on a point and right angles to the other. What's the magnitude of the resultant force in Newton? So this is a force of 3 Newton and this is a force of 4 Newton. The resultant force can be found by using the Pythagoras theorem. So we are going to use Pythagoras theorem. So the magnitude of the resultant force is gonna be 5 Newton. There's a 20 ohm resistor which is connected across a 60 volt. What's the current in this circuit? The energy used by the resistor is 10 seconds. So the voltage is gonna be 6 volt, and resistor is gonna be 20 ohm. So we are going to apply this equation. So the current is going to be 3 amp. This value 3 ampere. This is the answer of the first question, and we are going to find the energy. So the answer of the second question is going to be 1.8 kilojoules. So the answer of the first question is going to be 3 ampere, and the answer of the second question is going to be 1.8 kilojoules.